Let us now do some practical applications of total internal reflection of light. The very first application is based upon this concept of prism. This kind of prism, it is a right angled prism. I had told you about refraction through a prism that was equiangular or equilateral prism. But prisms can be of different shapes. This is an example of a isosceles prism. Isosceles means two angles are equal, and moreover it's a special kind of isosceles prism in which one angle is 90 degrees. So it is called right angled isosceles prism. A, B, C is a right angled isosceles prism. Now this angle is 45, this angle is also 45. Now I presume that this prism is made up of glass, and you must know that critical angle, I critical for glass is equal to 42 degrees approximately. Mostly for your questions, the critical angle for glass is given to be equal to 42. It depends upon various types of glass used, flint glass, crown glass, the value might vary. But for most of the questions we take on an average the critical angle of glass as 42 degrees. Now the question is asked like this: these rays, let us say rays P and Q, are two rays which are made to fall on side AB of a right angled prism as shown in the figure. Trace the course of ray as it emerges out. Now these rays are striking on this prism on side AB at right angles. The normal incidence. So as we have studied before, in accordance with the laws of refraction, this will go unbent. The rays will go straight. So this ray goes straight from here because it's a case of normal incidence. Hits the side AC. Ray goes straight from here, no bending because it is striking this side at 90 degrees, and it strikes this side AC over here. Now once it reaches AC, we draw a normal at this point. At this point where it meets the side AC, we draw a normal. There it is. Now if we look at this small triangle over here, now this angle is 90, this angle is 45, this angle is also, it can be calculated by geometry, this angle is also equal to 45 degrees. Now since this is a normal, therefore this whole angle is 90, and this whole angle is also 90. This much is 45, then this much, this angle is also 45. Now for this point, this becomes the angle of incidence. If the ray were to come out from here, the angle over here, this angle will be angle of incidence. And how much is it? 45 degrees. And critical angle is 42 degrees. So angle of incidence becomes more than I critical. Angle of incidence is more than the critical angle. And since the angle is more than the critical angle, the ray cannot go out into the air. That's air. This prism is made up of glass. Glass prism, so angle of incidence is more than the critical angle, so the ray cannot go out. The ray will get reflected, totally internally reflected from this point. So ray gets reflected over here like this, and this ray strikes this side BC again at 90 degrees and goes straight like this. So this angle is 45. Since the ray is reflected ray, this angle is also 45 degrees. Similarly, this angle is also 45 degrees. So you need to mark all these angles for at least one ray. You need not mark for all the rays, but at least for one ray you must mark these angles. So one ray is complete. Now similarly for the second ray also goes the same way. From here, strikes the prism here, and from here it bends by 90 degrees. The ray emerges out. The ray has turned by 90 degrees. The emergent ray has turned by 90 degrees. So they can ask you a question, how can a TIR prism, totally internally reflecting prism, be used so as to turn the ray of light by 90 degrees? So you have to draw this diagram over there. Similarly, second ray, same thing. If you want, you can mark the angles, but it is not necessary. You must mark all the angles for at least one ray. So ray P, let's start from here. P goes from here and here. Let P dash be the image of this point P. And similarly ray Q starts from here, reaches here. So Q dash is the image. Let us say PQ is the object. PQ is the object. The head of the object is at P. So head has turned here. P dash becomes the head. We find the image. This is the object. PQ is the object. And PQ dash is the image. And image has turned by 90 degrees. Object was like this. And the image has turned by 90 degrees. How can the ray of light be turned by 90 degrees? You should be able to explain this. You should be able to draw this diagram. Now we have another situation in which we have got two prisms. ABC is one right angled prism and DEF is another equilateral right angled prism. Now since they are right angled prisms and they are also equilateral prisms, so right angle means one angle is 90. Other two angles must be equal. The other two angles sum should be equal to 90. So each angle is equal to 45 degrees. So we mark it. This is 45 degrees, 45 degrees, 45 and 45 degrees. Each angle is 45 because each angle is a right angle prism 90. Total sum is 180. So other two should so add to 90. 90 plus 90 is 180. So this plus this is 90. Each is equal to 45. Now ray Q is incident on side AB. It strikes here at 90 degrees. Normal incidence. Ray strikes normally. And in accordance with law of refraction of light, when the ray strikes normally, it goes straight and reaches the side AC. Now at point AC, we draw a normal. Draw a normal. Now again in this triangle, 90, 45 as we did before. This is also 45 degrees. Now we will see. Angle of incidence I is more than critical angle. Critical angle is how much? For glass, critical angle is 42. So here angle of incidence is equal to 45 and the glass is a denser medium. Ray cannot go out into the air. So it will get reflected. We know that it will get turned by 90 degrees. So ray gets reflected here. Now the ray turns over, gets reflected. So this is the reflected ray. This angle is also 45. That is also 45. This is also 45 and that angle is 90. So the ray turns by 90 degrees. Now ray goes straight. It reaches side BC. Now it strikes here at right angles. Goes straight, unbent, straight. Then it strikes FE. Side FE. Again it strikes normally on this prism. The emergent ray of this becomes the incident ray for the second. So this ray strikes on face FE at 90 degrees, goes straight and meets side FD. Now at this point we draw a normal. Now in this small triangle, this angle is 90, 45. This angle is 45. So angle of incidence becomes more than the critical angle because critical angle is 42. The ray cannot go out. It will get reflected back into the same medium. So ray turns from here by 90 degrees. This way the ray turns by 90 degrees. The ray goes here. The ray emerges out from here. This angle is 45, 45, 45. This 45, that is 90. Normal emergence. Ray emerges out and comes out over here. So ray has gone like this. Similarly, second ray now, P. The Q ray is already marked, so we say Q dash. Now we start from P. Same thing happens to P. It turns from here by 90 degrees, reaches here. We draw normal. The ray emerges out over here. This is P dash. The ray goes down, emerges over here. Again, if you want, you can draw the normal here. Normal 45, 45 and 45. This is also 45 degrees. So like that. If you want, you can draw normal here also. But at least in one diagram you must draw 45, 45 and 45. So ray turns and goes over here. So PQ is the object. Let us say PQ is the object and Q is the head. So Q is the head. P dash Q dash is the image and PQ is the object. PQ is the object and P dash Q dash is the image. So it's like this. So Q and P. Yeah. The image has not been inverted. Image remains the same. So you need to practice this diagram. For your home assignment, please practice this diagram. Very neat and clear. It's a question based upon ICSC. This is object. This concept is used in making the periscope. Making the periscope in small classes, we used to make the periscope with the help of mirror. We used to attach two mirrors over here. But in senior classes, we'll tell you, you will not make it with mirrors. Rather, we make use of TIR prisms. Two prisms. How are two prisms arranged inside a periscope? So this is how you have to show. So object is over here and image is seen a bit down. You know, that's how periscope works. Similar situation is also used in cameras. This kind of situation is also used in making the cameras. Well, now we have another orientation of the prisms, TIR prisms. So here we have two prisms kept in this way. The right angle prisms, this prism number 1 and prism number 2. Two rays of light start from P and Q. Let us take ray P. Now this ray P, when it strikes this over here, normally goes straight, reaches the side. Let us call the side as A, B, C, D, E, F. So ray P strikes AB, normally goes straight, then strikes BC. Now here angle of incidence is 45. Now angle of incidence is more than the critical angle. Why? Because critical angle is equal to 42 degrees. 45 is more than 42. Ray gets reflected inside. It goes straight from here, reaches here. At point AC, at side AC, it goes straight out. Normal incidence goes straight over here, goes straight inside. Normal incidence reaches here. At this point, we again draw a normal. So we can calculate this angle. This is 90, this is 45, this is 45. Again, I is more than I critical. So ray gets totally internally reflected. So this was ray P. P reaches here P dash. Similarly, this angle is 45. This angle is 45. Now, put the arrows, the emergent ray. Similarly, this ray also turns by 90 degrees. Again turns by 90. It turns by 90 degrees twice. This way. This is ray Q. So this is Q dash. So PQ is the object and P dash Q dash is the image. This is the object. we find the image has been turned by 180 degrees. Image has been turned by 180 degrees. So ray goes from here 45, 45, draw normal here 45 and 45. That's how. An important question from examination point of view.